So this webinar is sponsored by the Graduate, Postdoc, and Technician Network Volunteers. They are a dedicated group of volunteers, graduates, postdocs, and technicians, as the name suggests, who create events for the Planchine community. And if you're interested in joining, you can find the application on the Planchine website. I'll also post a link in the chat momentarily. If you have any questions, you can also email me as well. So with that, I'll introduce our first speaker, Michael Cacciatore. Michael Cacciatore earned his PhD from the University of Wisconsin-Madison and is an associate professor and assistant department head in the Department of Advertising and Public Relations at the University of Georgia. His research focus is science communication, with some of his most recent work exploring humor as a strategy for engaging hard-to-reach publics with science content. He also serves as co-director of the Grady Center for Health and Risk Communication and is the associate director of the C-Suite for Social Media Engagement and Evaluation. Thank you for being here today, Michael. You can go ahead and share your screen.
Thank you, Amy. If you heard the various titles that I have, they're all like co or assistant because I don't think I'm capable enough to do things on my own. So,
Oh, I'm sure that's not true.
sorry, my
There's
share
that humor in science.
is my share now working?
Yes.
All right, now I just have to get it into slideshow mode here. Perfect. Well, thank you, Amy, and welcome everyone for joining us to have a little talk about science communication here. In the interest of time, I'm just going to jump right in. So, this is the roadmap for what I'll be talking about today. I'll talk a little bit about trust, including the issue of is there a crisis of confidence in science and scientists? From there, I'll get into one of the central questions around science communication research. What do we want to inform or engage? And then finally, I'll spend the bulk of my time talking about something that I thought would be probably the most engaging for this group. It may not be the most relevant, but I think it's some of the most interesting stuff that I'm doing. It looks at humor as that engagement tool for science content. So let's jump into trust. So this is a screen grab from a Pew Research report. You may not have seen this specific report, but you've probably had discussions or encountered similar headlines, right? This idea that public confidence in science and scientists is going down. And the data is accurate, right? This is a reputable company collecting this data, and certainly there has been a drop in trust or a drop in public confidence in science. But what I want to do is kind of pull us back a little bit and provide some context. Because as you can see here, there's been a drop in terms of confidence in the military. And as my next slide will show, a host of other major institutions. And so I think what we're seeing is not so much a crisis of confidence in science, but kind of societal movement away from confidence. So this is the United States is kind of feeling less confident in a number of different institutions, one of which is science. That said, you can see here that scientists remain one of the most trusted groups in society. From this image, they're actually the most trusted group, depending on how you want to break down the data. So I think this is something to celebrate. This is a reason for optimism, right? Confidence is quite strong. And I think more importantly, it's been that way for a lengthy period of time. So this figure I'm about to animate goes back to the early 80s through to 2024, and I'm going to chart the percent of people expressing a great deal of confidence in the people running these different institutions. So we'll start with the press. It's not dramatic, but you can see that over time, it kind of peaked at around 20% of the public expressing that great deal of confidence, and now it's into the single digits. So a decline over time. Here it is for organized religion. I live in the quote unquote Bible Belt here in Georgia, but you can see here nationally, there has been a decline in confidence in religious organizations. In comparison, this line, while not dramatically so, is actually much more stable. So this is the confidence in the scientific community. What you see here is, for the most part, it's kind of, had its peaks and valleys, but it's stayed in that 40 to 50% range. Yes, there's been a recent decline post-pandemic, and we'll get into that in a little bit. And then just for context, I use the military because they're oftentimes one of the most trusted institutions in the United States. You can see the peaks, and as you might imagine, they take place around kind of those rally around the flag times during times of conflict or war. But again, not as stable as the confidence that people have in scientific institutions. All right, that's the end of my optimistic outlook on things. Now we get into some of the more pessimistic stuff or some of the problems we're seeing. Right, when you look at those aggregate trends, it masks key shifts. And you can probably predict where these lines are going to go without me showing them, but I'll show them anyway. This is that same information broken down by Democrats, independents, and Republicans. The blue line here for Democrats, you can see kind of a steady upward flow in terms of confidence, peaking around the time of the pandemic and then, dropping since then, but still at levels that are elevated relative to virtually any point in time. Second, I got some people coming in here to have lunch here. Second, we have independence. You can see pretty stable, but hitting that decrease post-pandemic. And then lastly, our Republicans, which is certainly the most troubling line here. You can see they actually started out with being some of the most confident in science back in the early 80s. And since then, there's been this steady decline, really hitting a trough during the pandemic or post-pandemic before a small upward tick in the recent year. And then beyond that, beyond kind of this change based on different political groups, the type of science matters. Everything I've shown you up to this point has been looking at the scientific community in general or science as an institution. What you're seeing here is the percentage of adults who say they trust these groups a lot, and they vary based on topic. So the first one I'm showing here are MMR vaccines, and you're seeing medical scientists being the most trusted group. I think you'd want to see higher than 55%, but still, that is a majority of people put a lot of faith in the medical science around MMR vaccines. Probably more relevant for the people on this call. Here it is for the health risks and benefits of eating GM foods. Yes, scientists remain the most trusted group of the ones they surveyed, but they're not drastically ahead of small farm owners. So I think this is something that matters. We're with different issues, people are putting more or less stock in science or in scientists and the scientific community. All right, let's jump ahead a little bit to this idea of informing the public versus engaging them. I think the intuitive understanding of the world is that if we just provide the public with more knowledge about science, it'll make them more supportive of science, right? We're all rational people here. This is probably how many people on this call think. You learn about something, you learn the benefits and the risks, and ultimately scientists are trying to do a public good, so people will become more supportive. There is one flaw with this, and it's that the data oftentimes does not show this relationship. So for a number of different issues, there is no correlation between knowledge levels and public support for the scientific issue. For some issues, it actually ends up being negative. And here it is from my own data, looking at the topic of biofuels back when I was doing work at Wisconsin. As you can see here, as people learn more about the topic, they actually are more likely to perceive risks relative to benefits. And down here, you can see that as they learn more about the topic, they are less likely to report that the benefits outweigh the risks. So this is one of those issues where knowledge is actually a negative thing if you're trying to sell the science of biofuels. So why might we be seeing some of this? Well, there's not a lot of opportunity for people to learn about science in formal environments. You spend a relatively small slice of your life in school. Where are we encountering science then? Well, entertainment programming is oftentimes a place where people encounter it. And as you might imagine, there are kernels of truth in a lot of that, but oftentimes exaggerated accounts of science. I put this little CSI logo up here because there has been work done that shows that the more people consume shows like CSI, Law and Order to a lesser extent, NCIS, basically the programming that my parents watch constantly throughout the week, it produces a bias in people where when they serve on mock juries, they have this expectation that every single crime scene should have DNA that immediately diagnoses the problem. So people are learning about science in a bit of an erroneous manner here, but from entertainment television. And as you might imagine, scientists are depicted in different ways on these platforms. I have a few different ones here. I have the sinister scientist. I haven't seen the movie, but I believe that is from the Minions. I have the professor from Futurama here, the weak or frail scientist. And then, of course, we have the science nerd or geek, probably made a little bit more chic in recent years by the program The Big Bang Theory. But again, not necessarily a flattering look at who a scientist is. And you'll also notice they're all male, which is another idea that the public has about science. So I use that as a transition into my current work, which looks at how can we engage audiences using content primarily on social media that's designed to be funny. So why am I looking at humor? Why am I looking at comedy? Well, we're looking at it because comedy is universal. You know, within individuals, there might be a varying appreciation for humor, but at the end of the day, we all like to laugh. We all like that positive feeling that comes with a humorous situation, you know, granted that it's a tasteful humorous situation. It is something that is incredibly prevalent all around us, but also on social media. And it has the endorsement of a number of different organizations and scholars. If I'm not mistaken, I believe the AAAS runs a science comedy night, or at least they have in the past. I know that for certain. And so we're being encouraged to use humor in our communications oftentimes, but we don't know a lot about its effects. Most of our information about humor actually comes from the world of advertising. So the guiding questions for the work we're doing in this space are what impacts does humor have on audience attitudes toward and interactions with science? And do those impacts vary by different forms of humor and a number of different contextual factors that I'll walk us through today? So I'm always hesitant to put this in. It's really trying to sell the approach that we took to our humor studies. But what I can tell you is that it gets a little granular. That's why I'm hesitant. But what I can tell you is that, you know, like I said, advertising is where we learn a lot about humor. In the communication space, we learn a lot about humor in political spheres. And the bulk of work done in that area will do something like take a clip from The Daily Show and compare it to a clip from the Weather Channel, where both are talking about a scientific issue, in this case, climate change. And, you know, those studies will randomly assign people to different conditions. And then at the end of the day, we'll learn that lo and behold, the humorous condition worked. And as rigorous scientists on this call, you probably realize that there's problems with that approach, right? You're not just isolating humor versus no humor. What you're doing is showing a clip and comparing it to another clip that vary in a number of different ways. In this example here, right, we have a different gender of the host. They're dressed differently. They have different arguments that they're making around climate change. So, you know, different graphics. There's all these different things that make it difficult to say, no, what drove those positive effects was the humor. And so what our work tries to do is get away from that and really, really isolate humor as the cause of any sort of observed effects. And it's very difficult to do that, as you might imagine, but we think it's important to try. And so this first study that we engaged in, we were trying to get a grant, and so we decided to collect some preliminary data on humor to see if we had some initial evidence that it's a positive or negative impact on public thinking or public engagement. We took an existing joke, this idea of an atom losing an electron and becoming positively charged. So something that's been around forever. You've probably even if you're not searching it out, you might have seen some version of this on social media or encountered it at some point in your training. So it plays off a pun. That's the typical joke, and I'll get to that in just a second. So we built four different conditions using this idea as something that could potentially be kind of lighthearted and playful and ideally funny. So we built a no humor condition where we just give the facts, right? Atoms are composed of electrons, protons, and neutrons. When an atom loses an electron, it becomes more positive. Then we built the wordplay condition. Two scientists are talking. One says, researchers think atoms are losing electrons. Are you sure? Yeah, they're positive, right? There's the pun, there's the wordplay. Then we built this anthropomorphic version where we had two atoms actually doing the talking. One says, I've lost an electron. Are you sure? Yeah, I'm sure. It doesn't deliver the wordplay, but you can see from the image we have the happy atom, the sad atom, and a fleeing electron into the scene. And then lastly, we created a combined version where we have both the anthropomorphism and the wordplay. We realized that this is not laugh out loud funny, but that was kind of the point. Can we do something that's just a little bit playful, not over the top funny, and can it impact people? I also realized this is incredibly crude. Shout out goes to the person on our team that designed them. We did not have a cartoonist on the team, and so it relied on very rudimentary skills when it comes to producing these images. So we randomly assigned people in our first study to one of those four conditions, and then we just looked at this idea of how did it impact experienced mirth, which is how humorous, funny, or amusing people found the content. So the no humor condition has relatively low levels of this. The anthropomorphic condition has an elevated level, and it's significantly higher than the other group statistically. The wordplay condition ends up being on par with the anthropomorphic one, and the combined one produced the highest level of experienced mirth, and it was significantly different than all other groups. And so what we're seeing here is even with that joke that I have acknowledged is not the most over the top, hilarious, rah rah, laugh out loud type humor, it was able to produce this feeling of mirth among our respondents. But that's just one part of the equation, right? Okay, so we made people enjoy the content, but what does that do? What do these feelings of mirth translate into? So the first thing we looked at was a self-reported intention to partake in the Twitter conversation that was going on. So would people be willing to share? Would they be willing to retweet? Would they be willing to comment on? Would they be willing to like the conversation? And what we found was the people who found it more playful and enjoyable ended up saying, yes, I'd be more likely to share this in my network. I'd be more likely to like it, et cetera, et cetera, et cetera. Then we looked at actual commenting behaviors. And so on our survey, we actually left a blank space where people could add their own comment. And while not everyone took the time to do so, what we found was those who had higher levels of mirth were much more likely to, significantly so, leave a comment. And then, probably more important, we scrutinized those comments and we did essentially a mini content analysis around them. And what we found was they were overwhelmingly positive, the comments were. Very few people took the time to write something like lame or something negative like this is a lame joke, this isn't funny, that type of stuff. It was very rare to see that. And probably even more interesting, a good number of people tried to have their own witty comment that they added. And so they tried to have their own wordplay that they added to the puzzle, which we think is interesting because it suggests that people kind of are motivated to take the time to add to the conversation and even try to make it kind of a little bit more playful and kind of compound the findings that we had. What about other impacts that we have here? So a logical thing to look at is likability. That was in many ways kind of our entry into this world of humor. We anticipated that people would find this kind of playful content interesting and humorous, and in turn, they would attribute positive feelings to the person who posted it. And so again, we're looking at experienced mirth. And in this case, we're looking at motivations to follow more science content. By that, I mean not participate in the Twitter conversation that is present, but express a willingness to follow other accounts on social media. So to broaden their approach, to add additional accounts to their feed. So something that would kind of broaden the scope and expose them to science in a number of different ways. And then, like I said, we looked at perceived likability and found again this positive relationship. We have a scientist posting this content. If it made you laugh, if you found it humorous, you ended up thinking the scientist was more likable, perhaps defeating some of those stereotypes I showed you earlier about who a scientist is. And that also was an indirect path towards this. I want to learn more about science. I want to follow more accounts on social media about science. What I think is one of the more interesting things is that some of our strongest impacts, and there's a host of variables that this takes place with, but I'll graph one here, are taking place among these quote unquote hard to reach publics, people that are traditionally underserved when it comes to science. And so again, I'll animate this and show you these different groups, but I'm showing you a low science knowledge group, a medium science knowledge group, and a high science knowledge group. And we assess this with true false questions that are pretty common in the world of science communication research. And so what you see here is among people who have a strong knowledge of science, making them laugh enhance that feeling of, yes, I'd like to follow science more. Among those who have a medium level of knowledge, we see the same thing, but it's slightly stronger. So we're seeing a steeper line here, and having that experience of mirth is pushing them to follow more science content on social media. And then lastly, we have our low science knowledge group, and we're actually seeing the strongest effects for this group. So this is not normal. The vast majority of science communication research, when you really start looking at it, we're oftentimes preaching to the choir. The people that already care about science, the people who already have a knowledge about science, the people who are already following accounts about science. But here we're seeing very different effects. It's actually inverse here. And so that was our preliminary data that allowed us to write the grant. We ended up writing the grant. We were able to actually work with a person who had a background being a cartoonist, which was fantastic because they were able to produce much nicer graphics for our experimental stimuli. We essentially replicated everything I've been talking about on three different scientific issues. We chose microbiomes as kind of a low salience, it's not politically polarized issue. People don't know a lot about it. We chose artificial intelligence as kind of a middle of the road version of this, meaning, there's some awareness. This was done prior to ChatGPT being launched, importantly. So I want to note that. So it was before AI became like this very central topic in American culture. And then we did it with climate change. So a very salient issue, one that people have very ingrained, strong feelings towards, an issue that's heavily politically polarized. And all the stuff that I just showed you, all those positive impacts from humor onto kind of following science and all that type of stuff, we were able to replicate that when it came to microbiomes and artificial intelligence, these newer issues. But we did not see the same findings when it comes to climate change. So what are we seeing here? Well, it might be difficult for humor to really break through things where people have a very strong feeling already. They're already ingrained in their opinion, entrenched in that feeling. But for issues that have lower salience, humor might be a promising avenue for reaching those audiences and making them interested in science. So what did we do after that? We started partnering with different groups who had an interest in this. So we worked with this one group called Hello SciComm. They do outreach and they do stand-up comedy around this. So when they give talks about science, it usually has a humorous bend to it. So a study that we did with them, they were very interested in understanding what types of humor could they use. And specifically, they're interested in this idea of how aggressive can they be when they're talking to the public. And so they're interested in gentle satire versus a more aggressive form of satire. We live in a world of IRB, and so, we have to have these things reviewed. You'll notice that what I'm presenting here is not exactly like very aggressive satire, but it was more aggressive than the different condition here. So we had a podcast recording where we had a professional voice actor read through this idea about give an overview of enhanced geothermal systems. So for the gentle satire condition, they're saying enhanced geothermal systems can happen anywhere, just like love, but for renewable energy. The flip side for the aggressive satire condition changes the punchline to, it can happen anywhere where the herpes of renewable energy. So we tested this and found that valence matters. The aggressive condition ultimately hurt message credibility. And so we were able to establish that, yes, you can be funny, but you have to be careful about how aggressive you can be. Part of the explanation for this might be simply that it was delivered by a scientist, and people may not expect that level of aggression from a scientist who's supposed to be this neutral arbiter of facts. So we think it may be this kind of violation of norms or expectations. Next, we moved more into the contextual factors. And so we found a video that was on YouTube. It was done by, and I feel bad that I'm blanking on his name right now. I think it's Vince Ebert, if I'm not mistaken. He is a German physicist who also does stand-up comedy. So we found one of his videos online and we worked with some experts in the world of IT, and we had them, for one condition, remove the audience laughter from it. And so we were able to compare the exact same stand-up set, a version with no laughter versus a version with laughter. You can very much think of this like a sitcom that has a laugh track, right? And so what we found was indeed having that kind of audience prime, that audience kind of helping you along, saying, this is funny, I'm enjoying this, produced higher levels of this key variable, experience mirth. And then what does this lead to? Well, it made people believe that comedy was a valid source for scientific information, that this is someplace they can turn to, that there's value in this, that this is an appropriate way to reach audiences. What else did it impact? Well, I've already talked about likability earlier. It indeed did impact likability. People like the speaker more, the more they found the content to be humorous. And I think this one right here is critically important because when we brainstormed at the very start of these projects why we wanted to look at humor, we had a feeling that it would impact the likability of people. That seems somewhat intuitive, but the concern was it might make people kind of underestimate the scientist in question, the one who's using humor in their communications. We thought it might erode credibility or make them think, well, this person certainly couldn't be top of their field. They're being too playful. They're being too kind of glib with the content they're sharing. But we found it actually had a positive impact on the expertise of the communicator. People actually rated them higher on credibility and expertise. And in turn, both of these things end up again being significantly related to this idea that comedy can and should be used as a platform for reaching people. And then the last study I want to talk about here is it focuses on speaker characteristics. So we worked with Kasha Patel. She's at the Washington Post now. And she does stand-up comedy around DC, focused on science. Her whole set is about her background as a scientist. And she was interested in this idea of, do people perceive things differently if it's delivered by a male versus a female, a person who is African American or white, or based on their credentials? Are you labeled as a scientist or a comedian first? And so again, we work with Kasha. She recruited these different comedians from Washington and trained them in terms of how to deliver her set with the right pace, tone, emphasis, cadence, things of that nature to make sure the conditions were as similar as possible. And then we wanted to see, did people change their perception based on who is delivering the content? And this is one of those rare studies, or at least in our world, where null findings can be published and are kind of a very positive thing. So what we found was there was no gender bias. I know that there is some belief in society that perhaps males are funnier than females, or at the very least, we see a lot more representation of males relative to females in the world of comedy. Well, in this case, there was no impact based on gender. Similarly, there was no impact based on the race ethnicity of the speaker, and there was no impact based on whether they were labeled as a comedian or a scientist. And so I'm very close to my time here. I might be at it already. I just want to very quickly summarize what I've been talking about today. First, I wanted to simultaneously um, put the finger off the panic button while also putting it there a little bit and note that, trust in science, the credibility of scientists, it remains high. There have been declines, but in many ways, it just mirrors these other kind of trends in society. Everyday encounters with science, particularly in entertainment environments, are very important for shaping people's attitudes. It's not just textbook knowledge or textbook information that drives people to support or oppose science. They gain a sense of what science is and who scientists are from the things they encounter in their day-to-day life, including media. In many ways, I think this is positive. We can leverage these encounters by engaging audiences in the online spaces that they're heading to and by leveraging the language and style of those spaces. People have come to expect humorous content and memes on social media, so let's steer into that and look at that as well. And then lastly, humor shows pretty strong promise, I think, as a tool. I don't want to overstate it. I don't want to make the suggestion that everyone should try to be funny in their communications. We're looking at something that's pretty niche, but I think it's something that's pretty interesting as well. So we think there's promise in this space, but of course we provide words of caution around how you do it. Be a little bit more playful, be a little bit more benign. be careful about getting too aggressive or targeting different groups as part of that, right? It can be a risky strategy to make fun of climate deniers. That can be something that alienates that audience even further. So I think on that note, I am at time, and I'm not sure if we're doing questions right now or we're delaying, but I welcome any. And I think I'll stop sharing my screen to facilitate that.
Thank you, Michael. Yeah, that was really engaging. And like you said, it's kind of just a different perspective. And I know, like, I myself am afraid to kind of like use humor, but it's encouraging to see how accepted it is and how it can really boost your presentation. So we can do questions now, and then we will have Sarah's presentation, and then we'll also have some time for questions at the end. If you didn't see my message in the chat, please post your questions in the Q&A box. There should be a little box at the bottom of your toolbar that says Q&A. That helps me keep track of the questions. And we have two. So this one is kind of a couple of questions wrapped up into one. So we had someone say, it's interesting to see the positive impact humor makes on improving people's general perception of science. But do you have any insight into how humor affects the learning slash absorption of information? Do people remember the joke behind, or do people remember the science behind the joke being made? Is there a way to adapt this into more of a public education tool?
Yes and no. And so we have a little bit of data that suggests it is more memorable. Whether or not they remember it long term is it's a much more difficult approach to get longitudinal data in this space, as you might imagine. So we don't have any data on that. It is something that we've discussed. It is something that we want to do, and it's one of those things where if we can put together the resources, we would love to. So that's the first part of the question, Amy. I unfortunately don't have a pen or a notebook to take the notes. What was the second half of that question?
Oh, is there a way to adapt this into a public education tool?
I guess it depends what you mean by that, because I view, anytime a scientist goes out into the community, I view that as a public communication tool. It may not be the traditional sense that you're thinking of. I think in communications that go out on different platforms, on social media, I certainly think that's an opportunity. I think in public talks, I think it's an opportunity. I'm happy to elaborate if there's a more specific kind of toolkit we're thinking of, but those are the ones that pop into my head right now. I should quickly mention this. When I was in grad school and I was learning statistics, I ended up stumbling upon a book, and of course, I don't remember the author's name because this is just popping into my head right now, but it had a lot of playful examples in it and these weird scenarios, and it actually made statistics for someone who was a little statistically adverse at that time much more memorable. And it was a book that I kept going back to because I knew it had the information, but I also knew it did it in a manner that it presented it in a manner that wasn't as dry as your typical textbook. So, yeah, that's what I would say to that comment.
Thanks. Kara had the question, have you looked at or have interest in how humor or quote entertainment value affects how people may accept misinformation or the credibility of those who spread misinformation?
Yeah, so it sounds like the people on this call are sitting in on our brainstorming sessions because these are all things we're very, very interested in, especially misinformation. I've done a little work in that space, but it's mostly been literature reviews. We really want to dive into that space, both to look at it as can it operate as a corrective for misinformation? I think that's the first spot we'll go with it. But yeah, certainly, I mean, that earlier question about making content more memorable, certainly it can be a tool that can be used, hopefully to correct, but also it can be used as a tool to misinform if that is your goal, I think. So I say that with some caution because, again, I don't have the empirical data to back that up, but it's certainly something we want to look into and plan on looking into in the next couple of years.
This question is from Hagos. He says, how can we find the balance between credibility versus being funny and playfulness?
Yeah, I mean, I think in many ways it's always an internal line that you have to draw, right? You know your own comfort with this, and I do think that people have a pretty good gauge of what they can say and how they can say it in a manner that's playful before it starts crossing lines. I guess that we don't have a ton of data on the credibility, but everything we've seen actually ends up enhancing it, which are pretty excited about. Again, I think that can be used for negative purposes as well, but I think it can be very positive. So, that line is something that I think you have to determine yourself. What we were most happy to see was just being playful doesn't necessarily mean people take you less seriously. They can actually take you more seriously. So, yeah, we only have the one or two studies on that so far.
Great. All right, so we are going to go ahead and move on to our next presentation. Like I said earlier, we are going to have time at the end for more questions on both presentations. So if you think of something, go ahead and write it in the Q&A. You don't have to wait, just as you think of your questions, you can add them in. So I would like to introduce our next speaker. So Sarah Evanja earned her PhD from Cornell University. Oops, sorry, I accidentally exited out of my notes here. So sorry, she earned her PhD from Cornell University and is the Vice President of Business Development at Okanagan Specialty Fruits, where she works with stakeholders on biotechnology advances. Sarah's past experiences include founding the Alliance for Science, an organization focused on communicating and promoting plant biotech research alongside policy advocacy. Thank you, Sarah, for joining us today. You can go ahead and share your slides.
Great. Thank you so much, Amy, and thank you for the opportunity to be here. Just trying to get into the right mode here. I'm a big fan of the Plant Gene Network and all of the work you're doing, so really special to be able to join you today. As Amy mentioned, today I work for a really exciting company, Okanagan Specialty Fruits, one of the pioneers of plant biotechnology, as we were founded in 1996. So we're celebrating our 30th anniversary this year. And as I reflected on that, I remembered that 1996 was actually the year I fell in love with plant science. I was an undergraduate at a small liberal arts college. I was a biology major and didn't really know why I was a biology major, but it was interesting and didn't know what I was going to do with it. And I walked into a plant physiology class as an elective and fell in love with plant biology. And 1996 was a really exciting year in plant science because it was like the first year where we had massive commercial growing of genetically engineered crops. The following year, we would have the farmers first growing genetically engineered virus resistant papaya in Hawaii, and it was like it was such an exciting time for plant biotechnology, and that was in part what caused me to fall in love with plant science. So OSF was part of that movement in the 1990s, and it's just really exciting to see where the company has gone today. So I want to start with a little bit of background on Okanagan Specialty Fruits. So we were founded again in 1996 by Neil and Louisa Carter, who are in this photo. Neil continues to be our CEO today. And Neil, in his previous life, before OSF, he's an ag resource engineer by training, and he worked building farms in countries all around the world. He worked in about 80 different countries, spent a lot of time in Bangladesh and building, farms that would really contribute to that country's national food security program. Spent a lot of time in Sudan. Neil and Louisa raised their young kids in the Middle East and lived in Jordan for a long time until a war broke out and caused them to return to their native Canada, where they decided to build a farm of their own in British Columbia, growing apples and cherries. And in the act of becoming a farmer in the apple industry, Neil was pretty shocked at how many apples were lost due to browning and due to bruising when apples were being picked or when they were being transported in bins. and thought, well, this is unacceptable. We have to solve for this problem of food loss and food waste. And then, of course, apples we see as consumers get wasted as well due to browning. When we slice an apple, put it in our child's lunchbox, and it goes off to school and it browns, or we send a whole apple off in our child's lunchbox and they take one bite out of it and they don't eat the whole apple, and it comes home brown and really contributes to the food waste. And so Neil really set out to solve two problems: to reduce food loss and food waste, but also he wanted to increase the opportunity for apple and drive consumption of apple. And so those were the two problems that the company was really founded on. And again, it was 1996. It was the early days of biotechnology. And Neil looked around for a solution. How am I going to solve for food loss and food waste? How will we drive consumption of apple? And he discovered a paper out of Australia that showed that when you reduced polyphenol oxidase, the enzyme responsible for browning, you could actually reduce the browning reaction and thereby reduce loss and waste. And so he licensed that technology from that group and began working to engineer apples with suppressed polyphenol oxidase. So this was really the technology that our company was built on. We essentially turned off one of Apple's own genes, the gene that codes for polyphenol oxidase. And in doing so, we were able to reduce the expression of this enzyme and essentially make apples not brown when bruised or sliced. So this was the technology that really built our business. And with this simple biotech solution, we're able to reduce food loss and food waste. We've reduced the waste of our apple production significantly, as well as at the consumer level. But we're also able to drive consumption of apple by bringing apple into the fresh cut market. So while apple consumption was declining, the fresh cut opportunity for produce was on a dramatic rise. And that is the opportunity that we're able to capture by using these tools of biotechnology. So fast forward to today, we have developed 6 varieties of Arctic apples. They're being sold across North America, and consumers are really enjoying the benefits of bioengineered produce. So not only have we sold over 140 million servings of Arctic apples, but there are other really exciting products on the market as well. Del Monte has developed the Pink Glow pineapple, and we have over 1 million pineapples sold. It's an exciting product, beautiful to the eye. Another very beautiful product is Norfolk Healthy Produce, is high anthocyanin purple tomatoes. 80% of consumers surveyed say that they would purchase these purple tomatoes for the nutrition benefits and regardless of the technology used to develop it. So it's a really exciting time to be working in fruits and specialty crops and biotechnology. So with that introduction to the company that I'm so happy to work for, I want to introduce 5 principles that guide my science communication. So Michael did a fantastic job of sharing with us some of the theory behind science communication. And today I want to really focus on the practice. How do I talk about the science that we're doing at Okanagan Specialty Fruits? And I always like to keep things simple. So I'm going to share these 5 simple principles. The first, of course, is to know your audience. And I think the best way to get to know your audience, of course, you can do a little research before you give a talk or before you engage, but also to do a lot of listening. So listening, in my mind, is one of the most important aspects of science communication. To be able to listen and learn about what your audience cares about, how much they know, how will you relate to them before you even begin to share your story. Secondly, to share your why. Why do you do the work that you do? What motivates you as a scientist? What problem are you trying to solve for? That is so important as you embark on your science communication. 3, bring your characters to life. Every story needs great characters, and those can be people characters, or maybe it's the plant you work on or the crop that you're working on in the field. Maybe it's the person that shares the lab bench next to you, but the characters, there are characters in your story. It can even be you can be the character, but really to bring those characters to life because every story needs to have good characters. And then the fourth principle, to the best science explainers use an analogy. We have the opportunity of working on, some of the same problems day in and day out, and we can think of the best way to explain our science using an analogy. And then when we talk to a reporter, we're able to essentially offer that simple explanation, that fun way of relating your science in a familiar way in the form of analogy. We can serve that to the journalist, and then they can use that in their story as they're reporting on your science, or you can share it in your talk to connect with the audience in a way that makes sense and relates to their everyday life. So whenever I talk to reporters and I offer them an analogy, they're almost certainly going to use it as a soundbite, if it's an audio interview, or as a quote in the story. They love that analogy that relates to science. And so if you can think of the best analogy that describes your work and how to explain it, you can offer that in the form of a quote, and it's a great way to make sure you get a good soundbite. And then the fifth principle, a dash of data is good. Many times we can offer too many data points and too much data, but people do like a number or two to hang on to. And again, it is about knowing your audience. Like, how much data is your audience going to be ready for? And I think in most general audiences, it's really, you just need a couple of really strong data points. Okay, so going back to the way that I opened this talk today, I want to sort of share how these points showed up for me. So in the first slide, I shared with you our origin story. I talked about what motivated Neil and Louisa to start this company. And I hope that in doing so, gave you a sense of the story of OSF and the characters that have founded our company. In a second slide, I shared with you our why. Why are we using biotechnology? We're not just looking for a fun experiment to do, but we're really trying to solve real problems for growers as well as consumers. We're solving for food loss and food waste, a major problem in our food system. And we're really striving to drive consumption of a familiar fruit, apple, that is otherwise not being consumed readily. We're in the midst of a dietary crisis. We need to offer healthy options for people that are convenient and fit their lifestyle. So really trying to solve real world problems. I offered you a very subtle analogy for the work that we're doing. When I talk about how we are doing the science, it was a very light science slide, and I talked about how we're flipping a switch essentially to turn off one of the apple's own genes, polyphenol oxidase. And if I were talking to an audience of technical experts, I might not talk about flipping off a switch. I might use the words RNAi, the actual technical tool that we used to turn off expression of this enzyme. But for another audience, I might use that analogy of flipping off a switch. And so again, having those analogies in your pocket to use for the right audiences. And then a dash of data. I no longer show volumes of consumer data in terms of, how consumers feel about GMOs, whether they're likely to try or not try. I show these 3 data points. 1 million pink pineapples sold, 80% of consumers want purple tomatoes because of the health benefits, over 140 million Arctic apples sold. Enough said, people are excited about biotech products when they present benefits. So I hope that this is an example of how these 5 points can show up in the way that we tell our science stories. Okay, so just want to transition a little bit to some practicalities of science communication and how people who are doing science can engage in science communication. Today, there are so many ways in which we can get out there and talk about science. Certainly, we have traditional media that we've lived with for many decades, and that's still a really important way to engage. Many of you are at universities, and universities have communications offices, they have newspapers, they online papers, I should say. There are college news offices as well. And so it's really important, if you want opportunities to communicate about your science, that you let those offices know that you're out there, and you let them know about the exciting work that you're doing. So maybe you have a paper that's being published, or maybe you're doing a community engagement event. You can reach out to your university office and say, hey, I just want to let you know that we're going to be sharing our work in this journal article, and it's coming out next month, and we'd be happy to talk to you or talk to the press about it. So let them know that you're there. And then once they know about the work that you're doing, they're more likely to keep calling you when they need expert voices. You can also do communication through scientific societies. When I was a graduate student, I did a lot of writing for the American Society of Plant Biology, and they were fantastic. They even paid me to write for them. And so that was a really fun way for me to be able to practice my science communication as a graduate student. There's also opportunities with trade organizations. I know ASTA, the Seed Trade Association, as well as CropLife International, they've done a lot of really great interviews of particularly young scientists who are working in biotechnology and using these tools to solve real world problems. And they've featured a lot of those scientists in videos and articles on their website. And so there's always opportunities through different trade organizations to do science communication, company newsletters, your lab newsletter. Those are great places to get a good start. Now, in today's world, young scientists have so many opportunities to communicate their science through digital media. I mean, it used to be that you'd only get attention as a scientist if you were like the established senior scientist, head honcho in the lab, and that isn't the case anymore. You can really use digital tools to build your brand as a scientist and get your work out there. Even when you're a budding young scientist. So you can do that by using blogs. LinkedIn is a great place to engage in short form, sharing articles that are relevant to your field, sharing the work that you're doing. But also there's long form opportunities on the LinkedIn platform. So there's a lot of flexibility there. You can use Instagram. That's a particularly good platform for the visual aspects of the work that you do. TikTok is another really fun and popular platform, of course, where you can tell your story in more of a video format. And I think, just reflecting on some of Michael's comments about humor and how much humor to use and, what kind of voice and tone to use as a scientist, I think you can sort of modify your tone and kind of how you treat the topic differently based on these different platforms. So I think LinkedIn is a little bit more formal, where TikTok, maybe you can be a little bit more playful and a little bit more, incorporate a little bit more humor into your communication. So it's something to think about, like what is the right voice and tone for different formats. And then there's a lot of really great experiential ways to engage. I just gave a group a tour of our processing facility in our orchards yesterday, and that's a great way for us to communicate about the science that we're doing and show people how it manifests out in the orchard. Many universities have like open lab nights where the labs open up and you do demonstrations and you engage people in the actual doing of experimental science. There's lots of ways you can engage with your community, your Rotary clubs, your children camps, Girl Scouts, whatever it is. So many ways to engage in your community and share your science. And then, of course, we should be talking about the exciting science that we do in all aspects of our life, in the line at the grocery store, at church, walking down the street, talking to our neighbors. We should talk about science all the time. So there's no shortage of opportunities to practice science communication. Now, I talked a little bit about the opportunity of building your brand as a scientist, and I think this is so important because, as Michael says, scientists are highly trusted individuals, and so we need to get out there and really engage and share our expertise. It also helps us increase our visibility for job prospects. You can be a well-regarded, well-known scientist before you're even done with your PhD if you're out there communicating about the work that you're doing, commenting on papers that are relevant to your field on social media, can really build your credibility as a scientist and your reputation. You are an expert. There are so many people out there communicating misinformation who are not experts. You're an expert, so it's really on us as scientists to get out there and share our expertise. We also have the opportunity to be role models. Michael shared the images of male scientists that were sinister or old and frail, and that's not what a scientist looks like, right? We all look like all kinds of different people. And so it's so important that we're out there communicating, sharing who we are and why we do what we do so that we can inspire the next generation of scientists. Just as I was inspired in 1996 by all of the cool pioneering work that was happening in biotechnology. It's also a great way to increase the impact of your research. Yes, we publish in peer-reviewed papers, and that's important for certain metrics. But there's only so many people who read the peer-reviewed literature. And so you can increase the impact of your research and how it resonates with different audiences across society if you meet them on different platforms and communicate through different channels. And finally, we need more brand name scientists. We all know our favorite basketball star or our favorite soccer star. Let's all become brand name scientists so people can name a famous scientist as well as their famous soccer star. Okay, so what we write about or what we talk about when you are out there communicating something that you feel passionate about in science, it might be your research, it might be something that's not your research area, but you're still a scientist and you can discover the facts and share about that topic you feel passionate about. You want to communicate about information you want people to have. Inaccuracies you might want to correct or clarify based on something you've read, to promote something novel, new, or engaging, or to change people's behaviors, to get people to consider, adopt, accept, support. And I think this is particularly important in the area of plant biotechnology. So I want to just end with one more of my favorite ways of communicating, and that is through food. So I have here some of our Arctic apples. I'll put them in focus here, sitting before me. We finally have products that have been developed with genetic engineering that we can share and enjoy and eat. And people from the beginning of time have engaged in meaningful conversations and meaningful communication over food. It's really in our DNA to connect over the food that we eat. And so I think that's another really powerful way of communicating. And that was really what motivated us in 2019 to launch our modified food truck when I was at the Cornell Alliance for Science, where we thought, well, let's just meet people on the streets, let's meet people where they are and offer them the opportunity to eat genetically engineered food, because maybe people don't even really know what that experience is like. Let's let them taste and touch and feel these foods that they have these misconceptions about. And so I think really being able to communicate through food and with food is quite powerful. And on that note, I want to put in a plug for a session that we're doing at SIVB in June. I know I saw Ray is here with us. He's been instrumental in organizing this session where we are going to talk about some of these exciting foods that have been developed and offer the opportunity to taste Simplot's edited strawberry, taste the pink pineapple, the purple tomato, and the Arctic apple. So if you're at SIVB this June, please join us and enjoy connecting, conversing, and enjoying these biotech foods. Okay, so I want to just wrap up a little bit by honing in on gene editing, some of the new technology that many of us are working with. So people don't really know that much about gene editing, but when they learn about it, they're excited about it, particularly if it can make food more nutritious or if it can make food production more environmentally sustainable. And they cite things like reducing pesticide use and reducing water use. Now, In the US, these data here are from the US, where making food more nutritious is number one, where the sustainability dimension is second to that. If you go to Europe, that flips. And the driver for CRISPR acceptance is really around the sustainability dimension. And I think this is so important because this sustainability driver and this understanding that CRISPR and gene editing can play a really important role in helping us produce food more sustainably has had major policy implications for Europe and for the globe. So this has really been the driver for Europe to reevaluate and their regulations around biotechnology and decide that actually we're not going to treat gene edited crops as GMOs, and that's going to open the door for not only technology developers in Europe but also all around the world. Countries are looking at Europe as an example and saying, "Hey, Europe is changing their views on CRISPR and gene editing. We should too." And so it just goes to show that sharing the why of why we do this work, we're using these tools to solve real problems, to make our food production more sustainable. That can have major policy implications. Okay, so sharing the why is so important. Today at OSF, we continue to use the tools of genome editing to solve real problems for the industry. We continue to work on food loss and food waste by introducing polyphenol oxidase into other fruit crops using gene editing. We're working on nutritional security, not only by making fruits more convenient in this kind of grab and go format, but also by very directly introducing nutrition traits into fruits. We are working on climate resilience, tackling post-harvest challenges that are made worse by heat. We're working on disease resistance. In fact, our first edited product will be an example of this. And then tackling what is arguably one of the biggest challenges to the specialty crops industry, and that is of our increasing and very expensive, or high dependency on labor, I'll say, and the fact that it's not available and it's one of the biggest costs to specialty crop production. And there's so many advances in automation that are happening, but we need to really ready our crops for those advances in automation. And so using gene editing to essentially change the stature of trees and how we grow our trees, how the crop is essentially presented on the tree for easy harvesting by some of these mechanical means. So there's all kinds of problems that we can solve using these tools of gene editing, but sharing the why we're doing this work is so important. Okay, I want to just close with some insights on technology acceptance, some lessons learned from GMOs, and then ways in which we might move forward with new tools of gene editing. So the COVID era vaccine development really did a huge amount to help increase acceptance of biotechnology. We were all sitting around reading the news, waiting for these life-saving vaccines, and we learned that biotechnology had a really important role to play in developing those vaccines. So post-COVID, the halo around biotechnology, both in pharma but also in food and agriculture, is there, and attitudes definitely shifted during that period. Views of biotechnology are favorable among 62% of US voters. That's significant. And when voters change their minds about biotechnology, their views become more favorable 80% of the time. So the shift is towards a favorable attitude. Consumers are most accepting of gene editing if it brings a personal nutrition benefit or a sustainability benefit. And products are more readily accepted when they solve real problems. So we need to tell those stories. Products with consumer benefits changed the conversation around GMOs. We learned that transparency is key. So again, there's a huge role for communication to play in making sure that transparency is centered as we move into this new era of gene editing. And then finally, regulatory policies are shifting globally in a positive direction that will align with consumer acceptance. And those regulatory movements have really been informed by scientists getting out there and communicating with policymakers about the importance of this technology in solving some of the biggest problems that we face today. So what does all this mean for communication, Again, start with your why. That's always the most important place to start. We don't start with the science. We lead with, why are we doing what we do? Listen, learn about what your audience cares about. That's where you'll start your conversation. You can then connect on shared values or purpose because you've learned by listening what your audience cares about. And finally, seeing and eating is believing. And if we weren't in a virtual format, we'd be enjoying sliced apples together. But again, being able to see a field trial or eat a product of our science really does change hearts and minds. So with that, I want to thank you. Happy to continue the conversation beyond the context of this webinar. There's my email address. I'm also, of course, on LinkedIn, and happy to continue the conversations there. So with that, I'm going to stop sharing my screen and turn it back over to you, Amy.
Thank you, Sarah. And thank you both for your presentations. We had some comments going on in the chats and just saying thank you, and people really enjoying the talks. I do want to thank Sarah as well for the SIVB plug. So I will be presenting a poster, and then we have a plant gene workshop that will be happening at SIVB. So we'd love to see you there in Reno. Come by and say hi. And with that, we will go over to questions. So if you have questions for Sarah, please put them in the question and answer box, not in the chat. You can also raise your hand if you would like to just ask your question out loud. I did see a raised hand earlier, I think from G during Michael's presentation. So if you want to ask your question directly, raise your hand. You can raise your hand through the reaction button. So there's a little heart that says react, and then there's a raise hand button. So I can turn on your audio and let you communicate directly with the speakers.
Amy, can I just address one of the questions in the comments,
Sure.
actually, in the chat? Someone asked if Plant Gene was going to be at IAPB, and I'll let you answer that. So this is the International Association of Plant Biotechnology meeting that will be in Saskatoon, Saskatchewan in July. And I want to share that our lab at OSF is in Saskatoon. So we're really excited that IAPB is in Saskatoon this year, and we will be there. We'll be serving apples. We'll be opening the doors to our lab. And so I hope that anybody going to IAPB will come and get in touch and come and engage with OSF.
Great. That's great. You guys will be there. I'm gonna miss out, unfortunately. Yeah, we don't have, I'm not sure if people are going as individuals, but we're not doing a formal plant gene workshop like we are at SIVB. And then I won't be there personally. But yeah, it sounds like a great time. I can post the link in the chat too, to that meeting. So if people are interested in learning more, you can. But yeah, no, it sounds like it's going to be a good time, and a good location too.
Maybe there's another comment in the chat that's a little bit of a question about what do you advise us in Ethiopia as around gene editing or GM products? They're banned as a result of earlier biotech, and we are discouraged. And I know it is really discouraging when the tools you want to use to innovate and have impact with your science aren't allowed. And I think we just have to keep persevering. There's a great organization through the Ethiopian Institute for Agricultural Research that is advancing fantastic biotech communications. You have the Open Forum for Agricultural Biotechnology in East Africa that's doing a lot of really great communication to policymakers. And I think that, as Kenya really moves forward with gene editing, and Nigeria in West Africa is moving forward with gene editing, and other countries, Rwanda, start really using these tools to innovate in meaningful ways that contribute to the national economy, that contribute to food security. I think that really puts the pressure on other countries, neighboring countries, to also revisit their views and policies around biotechnology. And we see that happening. I didn't show the map, but the International Seed Federation has a map of all the countries in the world, and it indicates, whether they have begun the process of revising their regulations on gene editing, and whether they're different than GMO, and in almost all cases except one, when countries undertake this process, they decide, no, we're going to regulate gene editing differently than GMOs. And so that's really created a much more open environment globally. And then when policymakers in Ethiopia or other parts of the world see that map, it's like, wow, we better get on board. So I think just continuing to communicate is so essential to ultimately being able to use these tools to have impact. So we'll be cheering you on, but I think that it's really important to continue to push for access to these tools, no matter where you live. So thank you so much, Kasahun, for that comment and question. It's great to see what an international audience we have today. I'm impressed, despite all the time zones.
Yes, I'm always amazed at the people who turn up for these. Yeah, because the time zones, it must be really difficult, or really late, really early for some people. So it's great to see the dedication and the excitement for these topics. And I do want to remind people that we did record this, so it will be available on the Plangene website. So some of those resources and like the data we mentioned, you can look back at that. Great.
Great to see so many people who have been connected to the Alliance for Science onto from the Philippines and all around the world. So really, really great to see you all.
So Sarah, I just personally had a question because you had mentioned so there's new regulation in Europe regarding, I believe it's the CRISPR edited crops specifically. I don't know if you can expand on that a little bit more, kind of what is new, and maybe I don't know if you have any insight into kind of how this came about. Like you said, it's a lot of just communication, policy advocacy work.
Yeah, I mean, these are really important tools, the tools of gene editing. Just to take a step back, if we look at biotech 101 let's not 101, 1.0, let's say, and the impact that genetic engineering tools had on global crop production, it was significant, right? I mean, the number of farmers, the number of hectares, like it was a highly impactful technology. However, if you look at it from the perspective of how many crops benefited from the tools, and how many traits we were able to introduce using those tools, like 99% of all the GMOs out there really are just 4 crops and 2 traits and combinations of those 2 traits. And so when people say, well, GMOs really didn't live up to their potential, in a way, they're right. We really weren't able to use the tools to innovate as much as we would have liked, particularly in fruits and vegetables, for example, or consumer-facing traits, and that's certainly changing, and it's really changing rapidly with new tools like CRISPR and genome editing, where now governments around the world have said, okay, we have these new tools of gene editing. Are they the same as GMO or are they different? And countries across South America really led the way here. Places like Argentina and Brazil, who early on said, we're going to look at this new tool and we're going to, and ultimately decided that, this is different than GMO. If there's no foreign DNA that's part of the picture, then we're not going to regulate this as a GMO. It should be no different than conventional. And so country after country has gone through this process and basically, in most cases, come to the same conclusion. So if you look at that map that I referenced earlier, from the bottom of South America to the tip of Canada, like it's a green map, like green, let's go with gene editing, with a couple of exceptions like Mexico. So there's still some good work to be done there. places like Japan, India, Australia, like they're all ready to go with this technology. And so Europe is in the middle of going through this process, and it's looking very favorable. There was a decision last week where the council aligned with some of the compromise language that had been proposed. And so there'll be another decision, it's my understanding, another milestone next month, May 18th. But ultimately, they will have a new law that hopefully will enable European scientists to use these tools to innovate, and will allow the cultivation of gene edited crops in Europe, and will send a really important signal to the rest of the world that we're open for business when it comes to gene editing. And that's important because, of course, Europe is a major importer of crops. So even if there's the cultivation in Europe is an issue, but also many countries are watching what happens in Europe, because that's ultimately where the crops that they produce are destined to be. So it's a really important time. I applaud all of our fellow scientists in Europe who have been doing this important advocacy work to ensure that there's a positive outcome in Europe for this technology.
Thank you. Thanks for expanding on that and for your insights into the regulatory landscape. I have another question that I thought of while we were talking about this, because the stewardship is so important, but I think it's kind of a little bit of an unsexy topic for plant sciences. So we do polls for plant gene to all of these workshops, and topics are selected by the community. And stewardship kind of always polls like closer to the bottom. So at least that's been our experience. Maybe people who are more into the stewardships, I don't want to say it's an unsexy topic and offend people, but it's I guess I'm just kind of curious for like when we pick workshop topics and like workshop titles, how do you bring in audience that to important issues that maybe they're not personally excited about?
Well, I think that I'm not a stewardship expert, but I think I can speak, and I see Ray has some comment on this in the comment box. So encouraging everybody to read Ray's comment. But I think no matter what the topic is, whether it's stewardship, whether it's transposable elements, whether it's sugar transport, like there's a way to tell your story in a way that does engage an audience. And so I think, in the context of this communications workshop, I mean, that's what we're talking about. Like, how do we engage audiences in topics that might be sexy or might not be sexy in a way that ignites some interest and intrigue, right? And so again, Michael has provided some really fundamental theories behind, science communication. I think there's some clear, like practical ways in which I've tried to provide 5 tips for how to make any topic interesting. And so I think whether you're talking about stewardship or whether you're talking about sugar transport, there are basic ways to make every topic exciting and interesting. And again, starting with the why. Why do we need to talk about stewardship? Why is it important? I think that's the way to bring people in to a topic that they might not have been thinking about previously. And I think you have a volunteer in your chat for leading the stewardship conversation.
Yes, yeah. Ray, I'll have to reach out to you because it's something I know Wayne is here too. We've talked about to potentially doing like a stewardship workshop because yeah, it's a really important topic. But yeah, we have a pretty full few months ahead of us, especially with SIVB. But yeah, I'll need to be in touch. So I have a question from Hagos. I always wonder why advanced countries like the EU are resistant to GM crops and now gene-edited crops, while millions are going to bed hungry every day in many African countries. So I guess we kind of talked about this a little bit. It's not that things are changing, that we're seeing the regulations loosen. And people, consumers are accepting of these gene edited crops. But I'll let you answer his question on why do we see this resistance?
Well, I think that the positive news is that we don't see resistance in Europe. I think that people learned that they missed the boat on GM crops and that they've played a significant role in helping produce safe, abundant food. And they want to get it right on gene editing because they know that they need gene edited crops in order to achieve their sustainability goals and the Green Deal. And so I think the good news in Europe is that there isn't the resistance, there is an acceptance. And so that's really important. And it's going to be really important for countries around the world, including countries in sub-Saharan Africa. Many of those countries export to Europe. The political environment in those countries is influenced by decisions made in Europe. And so I think that as these key countries around the world embrace gene editing, that will have a positive impact across the continent of Africa and beyond. And the best thing that you can do as an African scientist is to make sure that your policymakers are aware of those changes that are happening in Europe and other places, and encourage them to look at the fantastic advances that are happening in South America, for example, on some of the same crops that are important in countries in Africa.
All right, so that was our last question in the Q&A. So if anybody else has some other questions, otherwise we can just end a few minutes early. If you do have a question, please put it in the Q&A, or you can also raise your hand. So again, this is the React button. If you click on that, there's a raise hand option, and that'll let me unmute you so you can talk directly to the speakers. But just while everyone is, I'm going to give everyone just a moment to think of their last questions here. I do want to say thank you again to our volunteers who planned this. I saw a few of them on the call today. I just want to say thank you again. This was planned by our graduate, postdoc, and technician network volunteers. We call them the GPT just for short, not to be confused with ChatGPT. But they are a really great group to work with. We meet every other month. And we discuss ideas for the group, start planning events, look for speakers, things like that. So if you do want to be involved in volunteering, not only for the GPT, but we also have a blog team. They do interviews. So if you're interested in science communication, which I know you are because you're here today, then join our blog team. They do great work. We also have some other groups like our outreach team and our social media team, which again, a great way to get involved in science communication. So I will put the link to volunteer in the chat. And also, if you aren't a Plant Gene member, register so you can get emails from us and hear about future events.
Thank you all so much. Thank you, Amy, for organizing.
Thanks.
Keep up the good work, science communicators.
Yes, thank you.
Yeah. Yeah, no, thank you both. I hope this was encouraging for everyone to get out there and do some science communication. So with that, just a final thank you to our speakers, and we'll see you guys at our next event. All right. Thank you, Sarah. Thank you, Michael.
Thank you.
Plant Gene would like to thank the National Science Foundation for their support. To learn more, you can visit their website at nsf.gov.